Hi all, my name is Dhruv Sharma and I welcome you all on a new session on load balancers with NSXT. Well, load balancers has always been within our networks to load balance the traffic to our servers. And there are various vendors available within the industry to do which does perform load balancing and provide a very good options to us. In this session, we're going to discuss about what NSXT as a native load balancing solution offers us and how we can use the NSXT as a load balancing solution within our data centers. Well, NSX as a solution, as a networking solution, can only be used in a virtualized environment, and it does offer a native load balancing solution. Why I'm saying native load balancing solution is because now NSX is now offering an advanced load balancing solution as well, which is out of scope of today's session. I'm planning to set up a separate session for advanced load balancing with NSXT in future. But for now, we're going to discuss about native NSXT load balancing solutions. So when I say native, it's like when we purchase or install NSXT in our data centers, this load balancing solution is available by default as part of the license. So when we have that NSXT in our load balancer, we can leverage this load balancing solution in our data centers. When we go through the steps, if you have already working on other load balancers within your data centers, you can easily compare with your existing load balancing solutions offered by F5 or NetScalers. You can see that which one is better, which one is providing more load balancing solutions. So on that note, let's jump in. Well, so I hope all the viewers of this video, they must have basic understanding about what NSX is, what are the building blocks of NSX, and how we can use NSX within our data center. So we won't be touching base about the basic building blocks about NSX, and I believe all the viewers of this video, they should have some reasonable understanding about NSX. Well, load balancing feature on the NSX can be enabled only on tier 1 gateways. It cannot be enabled on tier 0 gateways. That's the basic principle about configuring load balancers on NSX. And like any other load balancer, we can configure health checks on the load balancer. So what does it mean? That if you have a load balancer which has a VIP and which is load balancing the traffic between the two servers, we can configure health monitors on this VIP to make sure that the pool members it is trying to load balance, they are in good healthy state or not. If at some point the health check fails, it will remove the server from the load balancing pool, and it will only send traffic or only distribute the traffic to the nodes which are marked healthy. And using some application profiles, which we will discuss in some short period from now, we do have some options like SSL offloading, which is usually provided by other load balancers in the industry. Well, building blocks, it's pretty something similar. I think we all know, and like any other load balancers, we can configure virtual servers, we can configure pools, and we can configure monitors. Pool is the group of servers where we want the traffic to be distributed. Virtual IP is the dummy IP, which we configure on the load balancer. So VIP is a virtual IP, and these are the pool members sitting behind a VIP, and this is the user, happy user. So this happy user will be accessing the VIP rather than the servers in the background. Well, load balancing see, any vendor, if you approach any vendor, they have their best recommendations. What should be the best way you can configure load balancing using their solution. So NSX or VMware offers uh, suggests their customers to configure load balancing in three main design techniques. The first design technique is to use load balancers on tier 1 when they are inline to the traffic, which means that tier 1 gateways are inline to the traffic and the users are external. When I mean the external, it means that they are outside to the NSX environment. The tier 0 gateway have a BGP neighborship with Cisco IOS router. And the user accesses the VIP through tier 0 gateway, and tier 1 gateways load balance the traffic between the pool members. That's the simplest way of deploying uh, the 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 load balancers within our data center. Well, second option is one-arm load balancing, where the users in this case, they are sitting within the realm of NSX. The users are within the NSX, somewhere within the NSX segments, and they access the VIP through a tier 1 gateway. In this case, we have to configure SNAT on the load balancers. What it does is it translates when the user is accessing the VIP and trying to access the servers. In this case, it translates the IP address of the users, the end users, with its own IP address. For example, this is a user. That's an happy user. And it's trying to access a VIP on the load balancer. And that's the server. And if in case the user is trying to access the VIP through a load balancer, the load balancer changes the source IP of the user with its own IP and then sends traffic to the server. So the server, when it responds back, the destination IP of the server will always be the load balancer. This is primarily used to make sure that these servers in the response packet doesn't respond to the user directly and cause an asymmetric route. And I'm sure if you worked on the load balances in past, you know what I'm talking about. So this SNAT niche is we highly recommend to enable it when we are configuring in one-arm mode. The last option which VMware offers is to configure load balancing on a tier 1 gateway, which is not in line to the traffic. I haven't seen this option used much in past, but this option is available where tier 1 connects to a tier 1 gateway or a different load balancer interface. Well, coming back to load balancing mechanism, NSX offers only 5 load balancing mechanisms which you can use within your data centers, as mentioned in the screenshot. One is rounds robin, weighted rounds robin, least connections, weighted least connections, and HiPash. Well, rounds robin, everyone knows what this rounds robin means. It rounds robin the connection just on the first connection goes to the first server, the second connection goes to the second server. Weighted rounds robin is something where we can assign priority. Like if in case the server 1 has high CPU or is more powerful, then I can add a weight 10 to it, so that when the load is distributed between 1 and 2, this server gets 10 times more priority to server 2. I've given more details for you guys to read it. Least connections, I think as name suggests, the least connections are server 1 and 2. This server has 7 connections. This server has 3 connections. So the next connection will always go back to server number 3. But weighted least connection is used when there is a tie. For example, there are server 1, 2, and 3. Both server 1 and server 3 has a tie. They both have active connections of server 7. Now, if I've given weight 5 to server number 3, although server 1 and server 3 has same active connections, just because of higher weight, the new request will always go to server 3. Well, least connections, if there is not a tie, then it basically works in a round robin manner. An IP hash like is it just does a hash of source and the destination IP, and based on the hash, it assign a pool member, a pool or to one of the pool member from the pool to a client. Just for a lab sake, this is my lab topology, which I will be using for a demonstration, where we have a VIP that has an IP of 172.16.10.10, and these are the two pool members. I will be configuring my tier 1 gateways to redistribute this network into BGP neighborship so that our users can access it. We can set up load balancing in just 6 simple steps. The first step is to configure your tier 1 gateways, where when we configure a tier 1 gateways, we need to make sure that we advertise all NAT IP, LB IP, and the SNAT IP, as shown in this picture. Step number 2 is to redistribute the LB SNAT IP into BGP neighborship on tier 0 gateways. What I mean that there is a tier 0 gateway that is a BGP neighborship with iOS, Cisco iOS router, and behind them there are the real consumers of the LB VIP or load balancing VIP. And tier 1 gateways is the place where we have VIPs configured. So we need to make sure that these VIP IP address is advertised into the BGP neighborship. If we don't do it, the users will never be able to reach the network which is being used by the VIPs. Step number 3, we configure a load balancing profile. We can do that by going into networking and then the load balancing. And finally configure this name of the load balancing profile and connecting it to the tier 1 gateway. Finally, we can also configure the monitors. There are some set of default monitors which are available by default. We can configure HTTP-based, ICMP, TCP, and UDP. Where if we configure HTTP-based monitor, where we can basically configure a send string and a receive string. So what if I can configure our load balancer to query the pool member on this certain directory in the HTTP request, and we can mark a response, what we expect a response back from the server. And if the response is different, it will mark down the pool member. And finally, we can, on the step number 5, we can basically create a pool member and define the SNAT profile, what we can configure on the server. So there are various SNAT profiles, which are SNAT options, which are available, like in any other F5 load balancer, like F5, where we can configure auto map or define an SNAT pool IP addresses. Last step, but not the least, is the setting up the virtual servers. So like in like in any other virtual server, like F5 LTM, we can configure virtual server based on L4 standard virtual server or an advanced layer 7 virtual server, where we can configure a VIP and then which can be later associated with the pool member. I've given some more details of where you guys can read, get some more details about where to use and where not to use virtual servers for layer 4 and layer 7. So that should be it for this session, guys. Before we wrap up, I would like to discuss about some profiles as well. So I think if you worked on other load balancing solutions on F5 or NetScalers, we can, other than just doing normal load balancing, we can ask our load balancers to customize the load balancing traffic. So that's why we use application profiles. We can create TCP, UDP application profiles. We can create HTTP application profile or HTTPS based application profile with NSX solution, where we can configure HTTPS based offloading and SSL pass-through, and even X forwarders. So I think you guys know what X forwarders are, where the source IP of the user. So for example, this user is trying to access a VIP on the load balancer, and the VIP load balancer changes the source IP of the user and translates with its own IP. The source IP can be preserved in the HTTP field for various purposes like logging or what. So that preserving of the source IP of the users can be done using X forwarders, and we can do that using one of the application profiles. Well, that's it. And I believe now we can crack on, and I can give you a quick demonstration about how we can configure load balancers within our environment. Let me bring up my lab. Be with me. So within this environment, I will be using this lab. As you can see I'm sharing my screen. So within this environment, we have a tier 0 gateway. This has a BGP neighborship with a Cisco iOS router. And this BGP neighborship is currently up and running. Perfect. And we also have a tier 1 gateway, and which is mapped to two segments which are hosting two servers. So as I mentioned in my lab diagram, so these are the two servers, 172.16.10.11 and 10.12. They are the two servers connected to the linked segments. And finally, I've already configured my tier. I've configured my route distribution. I've configured my NAT IP and LBIP and SNAT IP to be re-advertised into BGP neighborship, the same step which I highlighted in my slides. So if you're configuring load balancing as a solution using the slides step-by-step screenshots which I've captured in my slide, I'm pretty much sure you should be able to achieve the objective. And finally, the tier 0 gateways. So the tier 0 gateways are already configured to redistribute the routes which are learned by tier 1 gateways, which are LB VIP, LB SNAT IP, and the NAT IPs. Without wasting any more time, let's crack on with the business. We'll go back on the load balancers, create a load balancing profile, and I call it as LB Web. And I attach it to a tier 1 gateway. And I click Save Changes. Well, it will come, we'll wait for it to come. In the meantime, we'll go back on the server pools. In the server pool, guys, I think I already created this in earlier, where I have added the two pool members IP addresses 172.16.10.11 and 10.12, and I attach it to a health monitor, HTTPS based custom health monitor, and I click Apply and click Save Changes. And I now go back and create a virtual server. So the pool member is done, and now we'll go and create a virtual server. So virtual server is a server which must have a VIP IP, and I can configure a VIP IP where it should be mapped back to the pool member. So I will connect this to a pool member web server, and load balancer is LB web. LB web is a load balancer profile which I've configured over here, and it should be web LB. And the IP address of the virtual server should be the 1.2.16.10.10. Port should be 443. I click Save Changes. This lab is on VMware HOL lab, so it sometimes act tricky. We'll wait for it to come up, and in the meantime, we can see the virtual server status is also unknown. So in the meantime, I can go and discuss about the health monitors, what we were talking about. So these are the default health monitors which are available to us. We can even create a custom health monitor where we can define the name test, and health monitor port is 80, and we can define the send string. We can define the complete URI of the server, dhruv.test.html, something of that sort. We can define the HTTP versions and click, and then we can even define what should be the expected receive string, what we receive from the server. So it can be, so this is the receive string which we should receive from the server. And if in case this string is not received, it can basically, mark the server down. So that kind of configuration we can do at our end. Yep, finally the server is marked as up. It does take some time, guys. So finally, I even talked about some application profiles where we can create some custom HTTP profile, or a TCP profile, or a UDP profile. The links I've already highlighted on the chat, on the slides, where you can refer and get more details about it. We can configure some fancy options like SSL offloading, fast TCP, fast UDP profiles, or various options are available which we can use within our environment. Finally, the VIP is also up. We should verify whether we can ping the VIP IP or not. Let me ping it. 172 ping 2.16.10.10. Yes, it is pinging. Now I will access the VIP through our VIP IP. Yep, it is indeed 172.16.10.10. It's a lab environment from the vendor. I think it will take a bit of a time, but we can see that the VIP is, yeah, it's reachable. So you can see that the VIP IP is resolving, and we can see it's been resolving into Web 1A and Web 2A. So we can confirm it now that the traffic is indeed getting rounds robin between the two servers, Web Server 1A and Web Server 2A. Well, I hope this session has been informative, and I thank you for viewing. If you have any questions, please drop those questions in the comment section, and I will get back to you. Thank you for viewing.